Alright, this is lesson 2.6 of our Pre-Calc 12 class. And I'm sorry I'm not wearing the flamingo shirt. Anyways, unit 2 is called Polynomials. Lesson 6 is called Roots of Polynomials. In this lesson, we're going to talk about what are the roots of a polynomial, how to find those roots graphically, and how to find those roots algebraically. So the roots of the polynomials are, you can think of them as the x values, or the x-intercepts of a polynomial. They're very similar to zeros of a polynomial. We usually talk about zeros from an equation, and we usually talk about roots from graph. However, they're slightly different. Okay, so if you look at this graph, if we think of the roots as x-intercepts, we can see there is one x-intercept at -5. So that means x plus 5 has to be a factor of this polynomial. Now, we can also see that if we do a vertical translation down, we can create two more roots, or two more x-intercepts. And so what we can do is, what that means is that we have what we call imaginary zeros. Zeros are roots that could be zeros if we did a vertical translation. The idea here is what those factors look like would be something like this. It would be x squared plus 4. If I tried solving that factor, setting it equal to 0 and solving for x, what we would get is an imaginary solution, or 2. So if x squared plus 4 is equal to 0, x squared would be -4. X would be the positive or the negative of the square root of -4, or plus or minus 2i. Don't forget the square root of -1 is just i, so square root of 4 is 2, square root of -1 is i. That's where the i comes from. And so we're looking for a factor of x plus 5 and x squared plus 4, so a would be the solution here. Okay, with this example, we have some roots that are not whole integers. So we do have we have an x-intercept at 5, so I know x minus 5 should be a factor. But then we have these two roots. One's between 1 and 2, and one root is between -1 and -2. So I know x minus 5 is a factor, so I'm looking at a or c. But then if I see the other factor in a, x squared plus 2 would be imaginary roots. Well, these aren't imaginary, they're just not whole numbers. So what we're going to say is these are probably irrational roots, as in there's some decimal number that cannot be written as a fraction. And if we check here, x squared minus 2, we can solve. It would be positive square root of 2 or negative square root of 2. And I know the square root of 2 is somewhere between 1 and 2, so this matches with our roots of our graph. So C would be the correct answer here. This would be the most likely, based off of those roots, this factored form polynomial is most likely the one that fits. Okay, when we talk about multiplicity, roots or x-intercepts are places where roots are places where we have x-intercepts. So at the x-intercept, our function can do one of two things. One, it can either cross the x-axis at that root, or, as in like right here, we have a root at 7, and the polynomial function crosses the x-axis. The other option is the root can just touch the x-axis, but not cross it. Or as I like to say, it kisses the x-axis. If we, like right here, there's a root at -2, but the function doesn't cross the x-axis, it just kisses it. And so if I see that, what that means is the root, the factor that gives us this root has a multiplicity that is an even number, usually a multiplicity of 2. So because there's a -2 root, I know x plus 2 is a factor. And because the graph kisses the x-axis, I know it's got a multiplicity of, in this case, 2. could be 4 or higher, but it's definitely got to be even. And our only options are squareds. So x plus 2 squared would be one factor, which I think 2 factors in this polynomial, and then x minus 7. So the last option would be correct. If we take that multiplicity of 2 idea back to the original y equals x squared, x would be the factor, so the root is 0, and it's squared, so it means we're kissing the x-axis. The parabola just touches the x-axis at 0, 0, but doesn't actually cross. Okay, some more examples. So if I had to say, here is the graph of a polynomial function, write a function that matches it. First thing we're going to do is identify the roots and pull the factors from there. We have 2 roots, one at -8 and one at +5. And the polynomial function kisses the x-axis but doesn't cross at each of those points. So each of those factors is going to have a multiplicity of 2. So we have x, because -8 is a root, x plus 8 is going to be a factor. And because it kisses and doesn't cross the x-axis at that point, it's going to have a multiplicity of 2. So x plus 8 squared is going to be one factor. Similarly, because +5 is a root, x minus 5 is going to be a factor. And then because it kisses the x-axis at that point, we're going to have a multiplicity of 2. So x minus 5 squared is another factor. And so what we've got to figure out though is there's some multiplier number that will make these two equal. I want to figure out what that is. So here's our setup. We're going to take the y-intercept, another non-root point. That would be an x value of 0 and a y value of -800. And we're going to take 0 and plug it in for x, and -800 and plug it in for our output, f of x. And then we'll have an equation with one variable, a. And then we can just solve this equation for a. So if we plug in 0 for x, we get 8 squared and -5 squared. It's going to be a times 64 times 25. And then we just solve for a and simplify our fraction. We get an a value of -1/2. So the function was going to have that a value, -1/2, times our factors with a multiplicity of 2 each. So that would be the final function right there in purple at the top. Alright, so if we were to just think about roots, are they real? Are they imaginary? Are they equal? Are they not equal? We can match up these graphs accordingly. So number 1, there's 2 roots, so they're real. If it crosses the x-axis, they're definitely real. The roots are at a different spot on the x-axis, so they're not equal roots, they're different roots, they're unequal. So this would be, 1 would go with b. 2 does not, the parabola in 2 does not cross the x-axis. So the degree of a parabola is a degree of 2, x squared. So there's 2 possible roots, but because it does not cross the x-axis, those roots are imaginary. 3, it kisses the x-axis just once. So degree of 2, so there's real roots because it crosses or touches the x-axis, and there's only one root. So you would say those are equal roots. If we tried solving this thing, we would get the same number. There's only one number we would get. That's how you know the difference between those 3. Alright, so hopefully you have some idea of identifying roots. They're kind of like x-intercepts, except that they're more encompassing because they include imaginary roots. We can look at roots and interpret them graphically and algebraically. Good luck with your homework.